In this video, we are going to present our innovative technology which would be used in manufacturing industry, that is powder metallurgy. The team member for our project are Noor, Danyal and Lukman. This outline is showing the flow of our presentation, which would be the definition of powder metallurgy, its advantages, process steps, applications, comparison between powder metallurgy and traditional methods of manufacturing, and in the last, conclusion. What is powder metallurgy? It is a metal technology process where a mixture of metallic powders are used to produce different solid parts. Actually, this technology needs two main production sequences. First one is pressing, which means compacting the powder, and second one is sintering. The compacted powder is heated to produce the final solid part. The question now is why we need this innovation? What's the value added behind this innovative technology? Actually, we have three main advantages in using powder metallurgy. It has better ability to make much less material waste. In fact, it can use around 97% of starting powder and only 3% of raw material is wasted, which means it is able to save more raw material, so saving more money as well. It has better ability to produce complicated shapes with better accuracy, so achieving quality aspects are better here. By the use of this technology, less subsequent machining is required, which means less expenses. What would be the manufacturing process steps for powder metallurgy? The manufacturing process is actually similar to the process of making a cake. We blend and mix the different metallic powders together the same way how we mix the cake ingredients. We press the powder and make it compacted in the specified shape in the same manner the cake mixture is pressed into the mold. Finally, sintering the compacted shapes to get a final part which is similar to cook a cake in oven. This is how the process would look like in a manufacturing industry, starting from mixing the raw material present in a powder state, then compacted to give the desired shape, then sintered it to make one bounded part. Starting with the first process, blending, which is following with the mixing of powder composition. For example, if we need to produce a part from bronze, we have to mix the copper powder with tin powder, or a product from brass, we have to mix both copper and zinc together. The step is important in order to achieve a good mixture homogeneity of powder's composition. Actually, in general, different devices can be used to perform this process. It depends on the use of composition. So each device makes specific for a property of metals to achieve a uniform homogeneity. Now press the mixed powder. Here a die is used to be filled with the powder. Then a force is applied to compact the powder. As a result, this powder would take the die shape, which is basically desired shape. Again, due to the different mixtures properties, different types of pressing can be applied to achieve the appropriate compaction, such as powder injection molding, powder rolling, or powder forging, and so on. Finally, the sintering process is done. It is a heat treatment process applied on the pressed powder. That is in order to melt the particles to fill the gap between pores. This step is important in order to achieve the maximum possible hardness and strength of the final product. Gear manufacturing is the most important aspect of powder metallurgy, and this application is considered as a huge blow to the manufacturing industry. Today, the entire focus of engineering world is on the gear manufacturing to achieve as much complexity as possible by powder metallurgy. We can also tailor the properties of gear by this process. Here is the comparison of two gears, one manufactured with powder metallurgy and the other one with traditional manufacturing process, which is hobbing here. By the comparing of these two, we achieve 10% greater tensile and yield strength, which is supposed to be a breakthrough in gear manufacturing. In this image, we compare cross-section of gears produced by both processes. It can be easily seen that the part produced by powder metallurgy has porous cross-section, which is the evidence of lightweight and high-strength part. To conclude it, powder metallurgy is a versatile process for producing net shape parts, which means no further machining required after production. High complex and unique shapes can be made by this process with good dimensional accuracy. This process reduces the machining scrap, provides excellent quality, and reduces the material waste.